Hi, I'm Yi-Shyuan from National Tsinghua University, and today I'd like to share a paper about user-system communication with a focus on smart home routine assistants. We can now preset the routines for smart homes, but what if homes get smarter? What if they can just do things for us? That would be amazing, right? With machine learning, it is possible. But adopting machine learning means that machines need to learn from their users. In other words, users need to provide feedback to better the system. User not providing ground truths will lead to systems giving out wrong predictions. Past studies have shown that when intelligent systems are not giving out right predictions, user would get mad, angry, and eventually want to abandon the system. In order to have smoother experience and interactions, systems need to explain why SHRS make those false predictions or urge users to provide feedback. Either way, user communication is crucial. That is why we are interested in knowing how systems should communicate with their users. More specifically, how should SHRS communicate with their users? For the scope of this study, SHRS stands for the abbreviation of Smart Home Routine Assistant. They are agents that predict residents' intended action on connected home appliances based on their routines and automatically perform those actions for them. We've invited 20 participants, 10 male and 10 female, to enact different designs and situations. By leveraging user enactment, we are able to gain insights into people's thoughts and preferences more efficiently. The study took place in a mock-up living room with SHRS simulated in Wizard of Oz style. In total, we have explored 7 different dimensions of SHRS, as shown in the slide. In a typical round of enactments, the participant would be assigned with a script. For example, it is a hot summer day and you want to turn on a fan. After reading the assigned script, the participants would be asked to take the actions they deem appropriate, such as walking toward the fan in order to turn it on. We tested out different situations where the predictions could be right or wrong. After each round of enactment, we would follow up with questions regarding their thoughts at the moment. Besides follow-up questions, we also interview participants at the end of every study. We aim to answer 3 research questions with our study, which are: how would people prefer to communicate with SHRS? What do people want to know when communicating with SHRS? Lastly, how do people perceive and assess incorrect automatic acts caused by false prediction? What would they do to better SHRS? Due to the time limit, I would share 3 main findings in 4 design spaces for future smart home designers in this presentation. The first part of our findings would be people's preferred communication style, whether a SHRS should ask for permission, notify only, or have no notification at all. There is no definite answer, but we found 4 factors that would affect people's preference. The first factor is the perceived possibility of being a wrong act. If the SHRS has high confidence, it won't need to ask. On the other hand, participant 10 commented that low confidence means it is not sure, and it should ask me. Participants' natural prefer level for user control also plays a part. Some naturally prefer to have more control over the system. Participant 7 has told us that just turn on the TV without asking me. I find it quite disrespectful, while others are perfectly fine for SHRS to do things automatically. The third factor would be the cost of an automatic act. If the system were to turn on risky appliance, such as gas, according to participant 16, SHRS should ask for permission. Other contextual factors would also affect participant preference for communication system. Participant 4 told us that weather could be one of them. If it was hot outside, it would be nice to have it automatically turn on AC for me, but if it were cold, it would be annoying. The second part of our finding is about confidence. Inspired by the common use of confidence in some consumer products and prior research, we have used confidence as our communication prompt and test out a variety of combinations. We didn't define confidence since we would like to know what people's natural interpretations are, though most are very similar, such as probability, possibility, likelihood, accuracy, certainty, etc. But there are also some interesting ones, such as how sensitive the system is, or a kind of urge or desire. It is not surprising that participants' inherent curiosity about the system would play a part in their desire. Some, like participant 14, for example, are naturally indifferent, saying that as long as it turns the appliance on for me, it is enough. I don't care much about how confident it is. Well, some still want to know about confident. Participants 12 told us that I feel better if I know the system at least is confident in what it does. If it does not show confidence, I would wonder why it even automates it in the very first place. The second factor is the perceived opportunity to interfere with automated acts. Participant 1 noted, if the system had already done it, it was unnecessary at the moment to know its confidence level. The correctness of automatic actions and participants' availability at the moment would also influence people's desire to learn about confidence. Participant 15 said, I don't want to learn about confidence now since I just got off work. All I want to do is relax. Our last main finding would be how people react when SHRAS error. People usually would go through 4 stages, though some would skip the correct phase. Participants would first assess whether they are correct, whether the exact appliance they want to turn on is actually turned on at the moment. If SHR's prediction is wrong, they would further assess whether the act is appropriate. It is interesting that participants did not necessarily see incorrect predictions be inappropriate. Participant 8 mentioned that as long as the false prediction made sense in the wider context of whether he foresaw himself turning the same appliance on later, he felt comfortable with it being wrong. In the diagnose stage, participants tended to diagnose SHRA's actions correctness by speculating about what information the system had collected, how it had predicted their intention, and why the automatic actions was chosen. Some participants would then move on to the correct phase, such as by telling the SHRAs that its confidence is too high or too low. Participants' availability was a key factor here, though participant 2 said, since the prediction was wrong, I would like to fix it now. We also have participant 15 explain, it is annoying to have multiple prompts for feedback in a short period of time. I would rather provide feedback all at once later. As well as wanting to give the SHRA real-time feedback, many participants mentioned that they would like to improve its prediction retrospectively. We found 4 different improving strategies. The configuration approach would be subdivided into 2 types. First, despite confidence being computed by the SHRA itself, many participants perceived it as modifiable and wanted to suggest the correct level of confidence the system should have computed. For example, participant 1 said, it said that it had 20% confidence. The confidence level should have been higher. I wish there was some way to adjust the confidence level upward. The second type was to reconfigure the measurements and thresholds the participant thought the SHRA had adopted to estimate their intentions. The second strategy was to teach the SHRA their behaviors. For example, participant 16 said that if the system erred, I would want to start retraining it. I could only train it by repeating my cue and gestures and giving the same feedback. For those who adopt the simplifying method, they would rearrange the physical configuration of the area so that the relation between home appliance and furniture would be more distinguishable. As participant 5 commented, I should place the AC remote further from the TV remote so the system can detect it better. The last strategy would be participants complying with SHRAs. They would adapt to the existing pattern that they perceive the system have learned from them. It should be noted that we have found some participants did not expend effort on improving the system, either because they thought doing so was the sole responsibility of product developers, or because they regarded themselves as able to improve it. Either way, their general reluctance should be noticed by the future SHRS designer. I would conclude this presentation with 4 design spaces inspired by our findings. During the onboarding phases, SHRS should first check the household's existing AI-related knowledge and mental models. It is vital to do so since such mental models would affect their future interactions with the system. SHRS should allow households to customize the system to their liking, such as to tailor how they prefer SHRS to communicate with them and how detailed explanations should be. Tutorials on how to properly give feedback to improve their system and how much training they need should also be provided. The SHRS should ask for permission to perform actions when it is first introduced into the household, since receiving regular feedback is important to better the quality of its prediction. Plus, it can remind its user that it is still learning. The key is to make households more comfortable with the system's learning curve. As its number of successful learning experiences increases, the SHRS may gain the trust of the members of its household. Once this stage is reached, it can ask the household member if it should continue asking for permission before performing those automated actions. Users do not always pay close attention to onboarding tutorials and have the tendency to skip those materials. So it would be suggested to occasionally sneak in brief tips, tricks, and quick facts about what information SHRS detect, how they learn, and how users can help them improve their predictions while the systems are loading. Finally, we would suggest SHRS to have easy-to-access dashboards to allow the members of their households to review all records of automatic acts and predictions along with explanations for them. Dashboards should also allow the users to modify all preferences they had previously set and allow more advanced configurations such as parameters for prediction and for deciding whether to execute an act. In this paper, or say presentation, we provided insights in regards of how and what SHRS should communicate with users, located 4 stages of reactions when interacting with SHRS and different types of improving strategies, and suggest 4 design spaces for future SHRS designers. Please refer to our paper if interested in more findings regarding how users interact with intelligent systems, and thank you so much for listening.